Scientist at Renzi. I've been here for 3-4 years. I have to take the thing with me if I walk. Look at that. I finished a PhD in 2011, was working on iRODS as a student, and thought it was so interesting that I hung around and I haven't gotten away yet. So I'm still here. I'm going to talk about the build and test infrastructure behind iRODS. I've given this talk a couple times now, and it's more interesting every year, I think. We'll see if you agree. This year we had a lot more help because it wasn't just me. Ben Keller did almost all of the work that I'm going to show you, but he doesn't want to come up here and talk about it, so he made me do it. He's in the back. You can heckle him later. So generally, the idea behind testing, for those of you who don't know what this does or why it's important, to make a nice general purpose slide here. The goal really is all about confidence. And that's confidence for different target audiences. Some of you in the room are some of those, and some of you are some of those. But generally, we get to solving your questions of confidence with these 6, 7, 8 bullets. And the goal really is to be transparent in almost all the things that we do so that there's no surprises on your end, perhaps so that you can even replicate it in your own infrastructure, to use the best practices that are out there, to show coverage for our own internal use so that when we start to refactor something, we know that we didn't miss a dark corner, packaging for installation and upgrade, and then the ability to run these tests singularly, as a group, as arbitrarily grouped, over and over again, just beat them into the ground, and then eventually you believe that they're doing what you think they're doing. The last thing that we've added is this ability to make them topology aware. This was the kicker for the last 24 months of work, basically, to try and get this thing to allow... To test a distributed system is actually pretty tricky. You have to actually deploy a distributed system, install all the things, get it configured, and then test it, and then tear it all down again to meet these other bullet points, right? To be able to run it over and over again, you've got to have that automated. So all of these steps really are to convince ourselves that this stuff works the way that we think it does, and then, of course, to be able to convey that in a clear way so that other people can either rerun it and believe that we know what we're talking about. To do that, the bulk of the work that we've done in the last year has been to get the zone bundle situation cleared up, written down in a schema, published, and then to use it. So 4.1, like Jason was saying, contains these integrated building blocks for configuration management. Those 5 files that are required for iRODS to now stand up are schema backed, and you can validate them over the internet. If you in fact have missed an item and you try to stand up your server, it will say, whoa, you're missing this thing, you should totally try and use this and it will work better. And if you try it, it will work better. These schemas are available on GitHub. We've got some for all the different types of files. One of these JSON schemas defines the zone bundle. These schemas actually depend on each other, so they are nested. The zone bundle is not actually terribly complicated because it just calls, it actually includes, it's nested, a server config, a resource server config, which then have the different config files and all the different core files, all that kind of stuff. So it's a nested system. They are all at that URL, and they're all public. The iZone report iCommand, like Jason was saying, produces one of these zone bundle files about an entire zone. And the key for us was, for the design principles, was to make it a round trip. So the 2 major things that it does, it allows us to debug stuff from the field at this point, i.e. our own deployments, because we may have a bug in our own deployment. But the goal eventually is to have someone be able to email, zip it up, whatever, an actual zone bundle result from a live grid in case you're having trouble. That's better than having it be communicated through an email without the actual details. Like if it has to be communicated in English, somebody's going to miss something, either in the encoding of that information or in the decoding of that information. So having the actual results is very important. The other complementary use case is for deployment of that exact same thing. If we now receive a bug report from the field with this attached, we can deploy your grid in our infrastructure. That's the theory. We've done it once now with our own stuff. We haven't yet received one from the field. But we're pretty sure that if the format's correct, we can actually deploy the same settings with the same core RE files, with the same host names, all that kind of stuff. We can do it in our own private cloud and be able perhaps to identify the problem, locate the situation, and be able to communicate with you much more effectively, much more clearly, and much more quickly. We think this is a big deal. So over the years, we've tried different things and learned a lot of things. We've got a paper about this that's going to be in the proceedings as well with more English and not just some arrows. We started with some Node.js and some Rabbit and all the things that you would find in a garden. And then we decided to not try that anymore. There were complications with Eucalyptus was starting to be overtaken by OpenStack. You know, community moves quickly. We went to OpenStack for a while. We were early in their development efforts, and it wasn't yet ready for what we needed it to do. So we quickly moved towards. Rincy already had a production vSphere installation that was more stable than what OpenStack had at the time back 2-3 years ago. This may not be the case anymore, but we're very happy with what we are doing now. So we moved to. This was all dynamic VMs. But we had some problems with different types of operating systems, different architectures and things. We moved to some long-running VMs running on the production side, and we started to minimize the extra moving parts. So that we just had Hudson as the CI driven by Python and installing and then running these VMs. The long-running VMs had a problem in that they were never fresh. So we had a lot of extra code at the beginning of all of our runs to basically clean up whatever had been there before from all possible combinations of what could have been run, which was a lot of work and never really satisfying in terms of being able to run the same stuff again. Ansible has become a thing. It's very stable, very robust now. So we moved to our own Jenkins server that no longer was kind of conflated with all of the other projects at Rincy as well. So at this point, iRODS development team is now in charge of this entire pipeline. We're using our own Ansible modules, which Ben has written. They're all online. I think they're on the last slide here, linkable. And these VMs, most importantly, are now dynamic again. They are not long-running. So every one of these, every time we run a job, we deploy a zone bundle. In servers are stood up. They are wired together. One of them is the iCat server. The other 2 or 3 or 4 are resource servers. iRODS is configured. They all get their host names. Tests are run. Results are gathered. And then the whole system is torn down at the end. So we have a completely reproducible system with full logging, and we can figure out what's going on. The clean slate was the key here. So when we first started doing this, the coverage on iRODS was about 20%. We've added a bunch of tests. We've gotten up to 59.2. We fight for every point percent at this point. The topology testing, surprisingly, after years of work, garnered an amazing 2.3% coverage. So that was surprising and not surprising. The topology coverage really only touches the few lines of code that do the redirects, right? So almost every operation, everything that comes into iRODS, the server says, is this for me? Awesome, I'll do some work for you. Oh, it's not for me. The data's over there. Let me shunt it to my friend. So that was 2.3% of the code, even though we did all that work. We estimate that the error checking code, we don't have any unit tests in iRODS right now. We have all our tests are functional. So they're basically from the outside. And so we ask it I commands, things happen, we get the result back. There are not many tests, there are no tests for the at the function level in the C++. That's one of our next big efforts to get that coverage to go up. But we estimate that the error checking is probably 14-15%. And then we're estimating, this is from direct observation and we'll call it a guess, that the untested features that were, the lines that we're missing are about 25% of the code base. things that are used by, I mean, obviously I think the things that are used by most people are extremely well tested. Our topology tests are defined right now fairly rigidly with one ICAT and 3 resource servers to capture the different cases. We expect that by this fall, certainly by next user group meeting next year, that we will be pushing the zone bundles down into the actual tests, and the tests themselves will become zone bundle aware. They can decide on their own merits whether or not to skip a test based on whether they are on the ICAT or whether they are on the resource server, whether they are running in an SSL environment, whether they are running in Kerberos land. These types of things, those decisions should be made as late as possible in the pipeline. Right now, they're being made a little bit earlier. So we want to push that down and make the tests a little bit smarter. It also means that other people can run these tests without having to know how the infrastructure works. The tests themselves will be able to figure out, oh, I can skip this test, or I can skip this whole suite of tests because they don't apply to this particular deployment. The other features we want to add, we want to move to CMake. This is a big deal in terms of our build infrastructure. There's a lot of things that I've had to learn and unlearn and forget and communicate to others about our current system. I'd like to just encode all that in a CMake project. Moving to CMake also means that all of the plugins that are not part of the core will also be able to piggyback off that CMake effort. So the plugins won't have to have their own build infrastructure as much. They can just kind of point to the super project and say, hey, where's my brain? It's over here, and it can pick up all the settings. I'm not sure if you're familiar with our current build. We've got an external directory where we use all the other things on the internet that are good to build iRODS, and those are right now tied to the version of iRODS. We'd like to get those separately versioned so that we don't have to do as much work to prep every time. If we actually don't change the external contents, we shouldn't have to actually rebuild them for every version of iRODS. So we've got an extra step in there right now that we have to handle. We would like the infrastructure to be able to test unpushed branches. So as a developer, right now, if I'm doing something with network code that's only going to apply to A, B, and C, and it's only going to get hit if it runs in a topology, there's no way for me to test that on my own machine or manually setting up multi-computer situations and hosting it. It's just a mess, right? I don't want to do all that work to test this one little thing. This infrastructure will be able to allow me to push my particular branch, my private branch that nobody else has published yet, into the same infrastructure, have it deploy that bit of code, even though it's not public. That's a really big deal for us to be confident that we're not pushing code that hasn't been tested yet. We're looking at putting a Garrett server, if you're familiar with Garrett, a code review step before we push to the live GitHub. We feel like we've got enough people watching this, enough people running this in their own infrastructures that we would like not to ever break the build. It doesn't happen very much now, but sometimes we still will push something that through some combination of esoteric thing, we missed a setting and the build actually doesn't complete. That will never happen if we have another step in the middle. And then, of course, we want to get federation testing automated. We've been doing it manually right now. We've got a pretty good little script, but it still requires us to set it up, run it, and configure this stuff itself. We've got multiple VMs. We've got multiple computers in a zone automated now, but we don't yet have federation with multiple zones automated. That's supposedly just another outer for loop. That's the famous last words, right? I have no other slides, but I can click on some buttons for you. The demos aren't terribly interesting, and there certainly won't be anything that runs in the time that we have remaining. They take about 3 to 5 hours to run these tests now each time we click a button. Do you have any questions about what we've done? I've got about 10 minutes on the piece of paper. If you want to go and click on things yourself, you can click on some of these. We've got, this is where all the schemas live, and then these are the testing repositories we have right now. This is doing the bulk of the work. This is the thing that is talking to vSphere. The way that this has been implemented, we could easily have iRODS testing provisioner OpenStack, and it would be very similar code, just talking to a slightly different API. So we can actually plug in different backends. So if you are interested in running this in your own infrastructure, you could use the same code, change a little bit of it, and you could talk to your OpenStack backend or whatever else you've got deploying your VMs. And then right now we've got a Git repository around the jargon library for Java that is also running in CI and fails less often than our stuff. Thanks to Mike Conway. Somehow he types all the things.